Hello, good morning. This lecture is going to be over the heart. And specifically, it is going to be over the heart chambers and valves. So, the last lecture that you watched should have covered the anatomy of the heart wall, right? We should have learned about the pericardium. We should have learned about the myocardium. We should have learned about the fact that cardiac muscle cells have some specific adaptations in order to help the heart beat your entire life. Okay, so please make sure that you have watched that video as well. It is very important that you understand the different parts of the pericardial sac, as well as understanding that the cardiac muscle cells are different than other muscle cells and that they're lined with something we call the epicardium on the outside, also known as the visceral pericardium. And then on the inside, we have the endocardium, which is going to be that same simple squamous epithelium that our capillaries are made of. Okay, so hopefully you understand where the heart is located, what it's made of, and then today we're going to get into the internal anatomy of the heart and some external. You have to understand what is on the heart in order to then see what's inside of the heart. So we're going to first start out by talking about the fact that the heart is two pumps. So I want you to know that there is something called the interventricular septum, which separates the left ventricle from the right ventricle. And that interventricular sulcus that's here has the coronary artery in it, one of the coronary arteries in it. And we're going to talk about those in a separate lecture, but those would be the blood vessels that run on the surface of the heart. Okay, so this coronary artery is going to run right down in between the left ventricle and the right ventricle. And it is going to separate the heart into the left and the right. Okay, and the heart has 4 chambers. So 2 chambers, the right atrium and the right ventricle, are going to work to push blood out of what we call the pulmonary trunk. And I'm coloring it in, and you can see the label at the top of the screen there. That's the pulmonary trunk. And pulmonary means on its way to the lungs or on the way from the lungs. Pulmonary means lungs, okay? And the pulmonary trunk is going to be the largest part of this blood vessel headed towards the lungs, all right? Okay, so the right side goes towards the lungs. So when I look at this diagram right here, I'm going to see that the right side of the heart goes out that pulmonary trunk and it's on its way to the lungs, and it goes both ways out the top of the heart. Sorry, my dog is distracting me. Okay, so the right ventricle pumps it out the pulmonary trunk, and it's going to go to the lungs to become oxygenated. Remember I said that lungs, we use the word pulmonary to mean lungs. This is what's known as the pulmonary circuit. We're going to call this for our lecture today Pump 1. All right, the pulmonary circuit is controlled by the pump on the right side of the heart. So remember, arteries move blood away from the heart. You're going to notice here that this is deoxygenated blood. It's blue. And that means that it's low in oxygen. But arteries, normally we think of arteries having oxygen-rich blood. In the pulmonary circuit, it is opposite. Okay, and it's sending that blood out to the capillaries in the lungs where it picks up oxygen. And now we switch it to a red color because it's got oxygen. And what do we call blood vessels that send blood towards the heart? Well, we call them veins. So this right here is a special circulation in the body where we have oxygenated blood traveling in the veins. Okay, so it's kind of a big thing to notice that in the pulmonary circuit, the arteries and the veins have opposite from what we normally see in the systemic circuit. And the systemic circuit, you'll notice here, we have head, neck, upper limbs. We have trunk and lower limbs. Your trunk is your torso. So your body, your trunk, your legs are attached to your trunk, your arms are attached to your trunk, your head is attached to your trunk. So the trunk and lower limbs is being fed by the systemic circuit. And that blood leaves, it goes into your body. The oxygen is dropped off at your cells in those capillary beds that we talked about. You must watch that blood vessel video if you have not already. If you have not attended that lecture, you need to. Okay, so the capillaries deliver the oxygen to the capillary beds, and then the veins pick it up and send it back towards the heart. And this time it's headed back to the right side. Okay, so going into the right side of the heart, we have the blood coming from the head and upper body and, well, all of the body. Okay, what's coming into the right side of the heart is the returning blood from the body, the systemic circuit. Okay, and then we have the blood, again, we said it was going out to the lungs. Now it's moving into the pulmonary circulation, the pulmonary circuit. It's going to become oxygenated, and when it returns, it's going to go to the left side of the heart. The left side of the heart is going to then pump the oxygenated blood out the aorta. Some of it will go towards the head, some of it will go towards the body. It will be deposited, the oxygen, nutrients, and so forth will be deposited in the capillary beds. In the capillary beds, the capillaries will pick up any carbon dioxide and waste products that need to be filtered, and then it goes back to the right side. So it's really important that we understand that this is two pumps. The two pumps, the right and the left, and they both send the blood to different places in the same circuit. Okay, so remember, when you see the blue, that means deoxygenated. But interestingly, here on the right side of the heart, I have an artery that's blue. I have veins, the vena cava, the superior vena cava and the inferior vena cava. Those are both considered veins. So I have both of the arteries and the veins blue. They're all deoxygenated, dealing with the right side of the heart. The left side of the heart, we have pulmonary veins, which are red, being oxygenated. And we have the aorta oxygenated, okay? So the left side of the heart deals with oxygenated blood, and the right side of the heart deals with blood that is low in oxygen. And we say low in oxygen because it always has some. Now, interestingly enough, the coronary artery runs down and shows us where the two separate. And the reason they do this is because this part of the heart, this part of the muscle, well, it really, really needs that blood in order to contract. It's got to have that blood supply all the way around the outside of the heart to feed all of those heart muscles with the necessary energy. Remember all those little capillary beds that have to be fed nutrients and oxygen to make cellular respiration take place. All right, so the aorta has connections to those coronary arteries, and what's inside of the heart is a whole bunch of muscle cells that need to be fed so that way the heart can contract. Here, right here, is what's underneath that artery I was showing you. Now try not to get confused. This one right here shows it coming down pretty much right like that. This one shows it coming down pretty much right like that. Okay, so try to remember that the place where we see that coronary artery on the front of the heart is the same place we're going to find the wall of muscle inside the heart. Otherwise, we just have an open chamber here that fills with blood. Okay, we don't need blood vessels to carry blood to the open chamber as much as we need blood vessels to carry the blood to all of those heart muscle cells, those cardiac cells. Okay, so hopefully this makes sense to you. With the fact that you now understand that there's a left side and a right side, and that the right side is responsible for our pulmonary circuit, and the left side is responsible for the systemic circuit. I'm now going to talk about how the blood moves through these chambers. So there's two chambers on each side. The A and the A here mean the same thing. We have right and left atria. And then on the bottom, we have right and left ventricles. All right. So the atrium and the ventricles are a little bit different. I will go ahead and tell you that you may want to write this down at this point. So pause the video and make sure that you have this written down, because we have a left and a right atria. The atria is where the blood comes into the heart. The blood then is moved to the ventricles. I talked about the fact that it's divided by a septum. And now the last thing that I need to tell you is that in the atrium, we have something called a foramen ovale. And the foramen ovale in an adult is reminiscent. It is the remains of a hole that originally appears in the heart during development. If you've ever heard of a baby having a hole in their heart, it's most likely this one. Okay, so what ends up happening is in the development of the heart, the blood is just kind of flowing around, and it doesn't matter which goes where, because all of the blood is being oxygenated by the mother that's carrying the fetus in her womb. Okay, so it doesn't really matter whether the oxygenated and deoxygenated blood mix at this point. And when a baby's born, well, if that hole is still there, then that's a problem, because normally what happens is this will grow closed through development. Okay, there's like a little flap that ends up growing, and it ends up sealing this off. So when it's open, it's known as a foramen ovale. But once it's closed, it's known as the fossa ovalis. So the fossa ovalis is what a normally developed heart will have, a closed foramen ovale. Now, the best part about the modern medicine is that doctors have figured out how to close this hole if it gets left open by inheritance somehow. If a child's heart stays open and that blood is going back and forth through this foramen ovale, that would cause an inefficiency in pumping the blood through the body. So doctors go in and they put a catheter in. A catheter is like a long tube. They can go in through a femoral vein and they feed this tube up into the heart. They feed it into the atria. This right here would be the left atria. This right here would be the right atria. And they can feed this catheter into this tube and they put in a little device. This was taken from a website that was selling the Starflex septal repair implant. Okay, so they have a little plug there that they can put in and close that heart opening. So this is a pretty simple procedure nowadays in modern medicine, and thankfully we're developing these things to help people who have these sorts of issues. Okay, so the atria are going to be those two top chambers of the heart. Here is where I'm coloring in the right atrium. Inside the right atrium, you can see the fossa ovalis. This is closed. If it was still open, it would be the foramen ovale. Okay, and then on the other side, we have the left atrium. Now, in between these two, there has to be a separator, and we call that the septum. So this is the interatrial septum because it's in between the atria, and it's a divider. Think about the septum on your nose. A lot of people like to pierce the septum these days of their nose. I think it makes you look like I don't know, I like it. I think it's cute, but it reminds me of the Tibetan cows that they lead around by the little circle on the nose. Anyway, okay, this one right here is an this time it's a ventricular septum. So this one says that it's going to be the septum in between the ventricles. Okay, so this right here is going to be the right ventricle. This right here is going to be the left ventricle. And you guys should take notice of this right here because on your practice pages and your packet pages, it's really hard to see what this is pointing to because this has a number. And I want to say this has this number. Okay, so when you're looking at these, it's hard to see what are they talking about. And this is the whole ventricle is what they're referring to with this line right here. Again, you'll see that on your packet. This line right here on your packet is referring to the right ventricle. This line on your packet is referring to the left ventricle. So again, left is right, right is left because we're thinking anatomical position. Your left is the image's right side. Your right is the image's left side. Okay, so left atrium at the top, left ventricle at the bottom. You're probably noticing these white sheet-looking things that are in between the two, and we're going to talk about those in a second. Those are known as valves. We actually talked about valves in the veins before when we talked about blood vessels. Okay, so the ventricles are the muscular pumps. Those muscular pumps are strong enough to send that blood all the way around the body for that circuitry. Okay, so remember that we are calling the heart two pumps. The pulmonary circuit goes to the lungs and then sends the blood back to the heart. Okay, the systemic circulation sends the blood to the head, neck, and arms, as well as the pelvic organs and lower regions of the body, returning the blood to the right side, So the right side sends the blood to the lungs to become oxygenated. That oxygenated blood is then sent around to the body and to the head and arms and lower limbs, where it becomes deoxygenated It then passes through back towards the heart, going back to the lungs to become oxygenated again. The chambers are separated by the septum. This septum is called the interatrial septum, atrium, atrial. The septum in the ventricles, the big, strong, muscular ventricle of the left and right, is separated by the interventricular septum. All right. Okay, so moving on now to those lovely valves we talked about. So I need you guys to notice that there's actually 4 valves. This one is known as the pulmonary semilunar valve, and it's right here. It looks like 3 little marshmallows maybe stuck in there, 3 little white beans or something, okay? That's one. We then have one hiding behind the pump. The trunk, the pulmonary trunk. Hiding behind the pulmonary trunk is another one of these, another semilunar valve. The one behind the pulmonary trunk is known as the aortic semilunar valve. The one that's in the pulmonary trunk is known as the pulmonary semilunar valve. All right? So those are the PSV and the ASV. A for aortic leads to the aorta. Pulmonary leads to the pulmonary trunk. Okay, so the names help you know where they belong. So once you start learning these words, you build upon what you know, and then you can construct knowledge, which is why I like science, because I have a hard time with memorization. So I always have to construct knowledge every time I do this. Okay, as far as the atria, which you know here at the top, going from the atria, notice the arrows, the red arrow here, blue arrow here. The atria is going to send the blood into the ventricles. So what you're going to have is you're going to have an atrioventricular valve. Okay, these are known as the AV valves. And the AV valves are, again, atrio being the atrium, ventricular being the ventricles. The atrioventricular valves are in between the atrium and the ventricles, and they make the blood continuously move in only one direction. Okay, so the tricuspid valve is in between the right atrium and the right ventricle. The bicuspid, or the mitral valve, is in between the left atrium and the left ventricle. And again, it's going to prevent blood from re-entering the atrium. We do not want blood moving out of the atrium into the ventricle and then back into the atria. No, what we need is the blood to come into the atria, go into the ventricle, and then go to the lungs. Or we need the blood to come into the atrium, go into the ventricle, and then go to the rest of the body. We do not want it going back into the atria. Okay, so blood flow is a one-way thing. All right. Okay, so let's look at what the valves look like specifically. And these pictures are on your packet practice pages. So make sure that you see that these are in your textbook, and they are here, of course. Okay, so this is kind of hard to see. I want you to try to imagine that we take the heart here, and I'm going to cut it right here so I can see all four of the valves. 1, 2, 3, 4. Now those four that I just colored are the same four here. 1, 2, 3, 4. Now it's hard to tell from this angle which ones are going from the atria to the ventricle and which ones are going from the ventricle to either the pulmonary trunk or the aorta. And I will tell you that the large ones are the AV valves, the atrioventricular valves. So here is one AV valve. Here is two AV valves. Now the thing that you need to see is that one is called a tricuspid because we have 1, 2, 3 cusps on this valve. On the bicuspid, we only have 2. 1, 2 on the open one. I'm now looking at this top portion again, okay? So we have 2 there, and here we have 1, 2, 3. All right? Now I want you to notice on the semilunar valves, both have 3. Okay? So only the strongest section of your heart has this bicuspid. All of the other valves have 3 flaps. Now, there's a difference between the valves that I'm going to get to in just one second, but what I want to make you aware of is that, again, we have the left bicuspid valve in the left side of the heart in between the atrium and the ventricle. Okay? On the right side of the heart, we are going to have the atria would be above here, and the blood is going into the ventricle, which would be below this white arrow here, down in here. Okay? So when the blood comes in, you can see that the flow of the blood comes right through these little cusps, they're called. The cusps are these little flaps. And in the bicuspid, there's 2. In the tricuspid, there are 3. But what I need you to notice is that these cusps are anchored to the wall of the heart. And they're anchored to the wall of the heart by something we call chordae tendineae. And it's so weird looking at it because these look like little strings. Think of them as little kite strings, little parachute strings. Okay, so when we think about a parachute, we have this parachute, and then we have all of these little lines that come down holding Mr. Parachute Man. Right, they would all be going to his backpack. Right? Okay, so we have this parachute, and all of these lines are holding the parachute open and in place. And you guys know that with a parachute, it's going to support the weight of a huge, well, not a huge, but a person's body, right? That's a big amount of weight. Like you think about big army dudes, like being 200 pounds, 250 pounds, no problem. A parachute holds them open. Okay, so that's a lot of pressure being held by all of those little lines. Well, here we have the same idea. We have all of these little lines, and then we have this flap here that's attached to these lines. And what's going to happen is when the blood pushes back on these, let's look at how it looks here. Do you guys see my parachute? Do you see a second parachute? It's like there's 2 parachutes, and these connectors, which we call chordae tendineae, are going to hold those valves in place. Look, here's my parachutes from the top. This is what my parachutes look like from the top. Here we can see all the parachute strings open. I'm sorry. We can see the distance in between the parachutes, whatever. I'm hoping that you'll see these chordae tendineae as these supports that are going to hold the cusp of the valve closed, because this is what happens. The blood flows through here, and then when the heart squeezes, these two valves shut, and they're held tightly together by the pressure of the blood. And then the strings hold them in place so that way they don't blow out and have blood go backwards, okay? Only your AV valves are going to have the chordae tendineae. Only your AV valves need the strength of the chordae tendineae to control the pressure. In the pulmonary valves, you have the flaps, and because of their design, they will close and they do divert the blood back. But because they're so small, they don't need the extra support of the parachute strings. Okay? So I hope that makes sense to you. Again, this is a pretty complicated idea. I hope that you guys ask questions if you have them. But again, you have 4 of our heart valves. You have 2 of the AV valves. Those are going to have the cusps. You're going to have 1 with 3, 1 with only 2. And both of the AV valves have that chordae tendineae that is similar to the parachute strings. Okay. And then we have 2 of the semilunar valves. These are going to be at the top of the heart. 1 pulmonary semilunar valve is on its way to sending the blood off to the lungs. The aortic semilunar valve is sending the blood off to the body, head, torso, and lower limbs. Okay, so there are a couple little video clips here that I'm going to add and show you.
Heart valves control the direction of the blood that flows through the heart. There are 4 valves, 2 regulating inflow, 2 regulating outflow. Notice how the valves snap shut when blood is pushed back against them. Real heart valves look and work like this. Tricuspid valve, pulmonary valve, mitral or bicuspid valve, aortic valve.
Okay, so I'll put the link to that in the box at the top of our agenda so you can watch that again if you want. I really want you to notice the flaps, and I noticed when I put it on the larger presentation full screen mode that it was hard to see the details. So you may want to watch this again, because here is the aortic semilunar valve here. Here is the pulmonary semilunar valve here. Here is the tricuspid AV valve. Here is the bicuspid AV valve, atrial ventricular. Okay, so hopefully that will help you see and understand these things. On this one right here, I'm going to play it. You can barely see these little flaps right here. And these are the valves in an ultrasound. So this will actually be, I think, even harder for you to see, but it's worth the shot. So we're going to watch this as well. Hopefully you're going to focus your eyes where I said to, and you can see those little valves open and close. Okay, so again, I will put these in the link so that way you can watch them again and make sure that you understand these things. Okay, so hopefully you are good with the fact that the heart is actually two pumps. Those two pumps, one pumps to the body, one pumps to the lungs. Pulmonary pumps to the lungs. The left side pumps to the body and other places. Inside your heart, you had a hole in your heart that closed at birth or was closed surgically. You have two atria that could have had that hole between it, or the one that closed when you were born. The ventricles are the large muscular chambers at the bottom. And then hopefully you have now learned the four valves. We have the larger ones, which go in between the atrium and the ventricles, the atrioventricular valves. And we have the smaller ones that go from the ventricles to either the pulmonary trunk on its way to the lungs or into the aorta, feeding the systemic circulation. This concludes our lecture on chambers of the heart and valves. Hope you enjoyed it.